Welcome to our deep dive, everyone. We're going to be looking at AI scaling laws today.
Yeah, it's fascinating stuff.
It really is. Exploring the connection between how well a model performs,
Right.
its size, the data, and the computing power.
Exactly.
We've all heard that bigger is better thing,
Oh, yeah.
more parameters, more data, and you get better results,
For a while, that was the trend.
right? But lately, it seems like things are getting a bit more interesting.
Definitely, yeah. Like, bigger is better has driven a lot of progress, but
Yeah.
um, we're kind of hitting some walls. Researchers are finding some really surprising things about how AI actually scales.
Okay, so let's break down this whole bigger is better idea first
Sure.
and look at that formula
Okay.
that everyone talks about. The
Yeah,
one that really got the scaling ball rolling.
right. The formulas, it can look kind of scary at first.
Yeah.
L equals L0 plus A over N to the alpha plus B over D to the beta.
Lots of letters and symbols.
But when you really get down to it, it's pretty elegant,
Right.
how it shows the relationship between model performance,
Okay.
the data, the parameters.
Yeah.
It all fits.
So before we completely lose anyone, let's
Yeah, huh.
could you break that formula down? Like what are all those letters and how do they connect to improving AI?
Okay, so L stands for the loss. Basically, it's how often the model makes mistakes. It's error rate.
Okay.
And L, that's your baseline loss, like the minimum error you'd get even with tons of data and parameters.
Gotcha.
Then you've got N, which is the number of parameters in the model, and D, which is the size of that training data set.
So the formula is saying that we can predict how well a model will perform just by changing the number of parameters and the amount of data.
Well,
That sounds almost too good to be true.
it's not quite that straightforward.
Okay.
The real trick is figuring out what those Greek letters, the alpha and beta, actually are. They're scaling exponents. They tell us how much changing parameters or the data size actually affects reducing that error.
So figuring out those exponents, that's where things get interesting.
Exactly. That's the real puzzle.
So how do they do that? How do researchers actually figure those out? Is it just a lot of trial and error?
There's definitely a lot of experimenting going on.
Yeah.
But it's not just random guesses. They're using really complex math and stats to see how model performance changes when they tweak different things.
Right, okay.
It's like a giant puzzle.
Makes sense. It's not just throwing more computing power at it or more data.
Right.
It's an actual science behind it.
Yeah.
But if this formula was so groundbreaking, why are we starting to see people moving away from just making bigger and bigger models?
That's a great question. And it brings us to some of the
Yeah?
really interesting findings that have come up recently. There was this study, the chinchilla scaling research.
Okay.
It kind of shook things up. They found that a lot of these huge language models were actually undertrained.
Undertrained for their size.
To their size, yeah.
So even if you've got this massive model, if it doesn't have enough data to learn from, it's not going to perform well.
Exactly. That's the key.
Mm.
Chinchilla scaling, they propose this ideal ratio between training data and the size of the model. About 20 tokens per parameter.
Okay.
That's for the best efficiency.
So just making the model bigger and bigger isn't necessarily the best way to go.
Right.
Are companies actually using this 20 token thing?
Oh, absolutely.
Hmm.
This research has really changed the way they build AI models now.
Interesting.
Companies are paying a lot more attention to that data-to-model size ratio.
Okay.
They're focusing on getting larger data sets and better quality
Makes sense.
to match the size of their models.
So it's not just bigger is better anymore. It's more about
Right.
a balance
Exactly.
between data quality and model size.
Yep.
What other things are researchers looking at as we explore these limitations of just scaling up?
Well, one of the most exciting areas is inference scaling.
Okay, inference scaling. What's that?
It looks at how a model performs when it's actually generating outputs,
Okay.
not just during the training phase.
So instead of making the model bigger,
Right.
we can make it better by giving it more time to think during that inference stage.
Yeah, kind of like that. It led to some pretty impressive results.
Interesting.
Imagine a language translation model. It can take more time
Right.
to think about the context before giving you a translation.
Right.
So you get a more accurate, nuanced output.
Makes sense. It's like giving someone more time to answer a question.
Exactly.
They might come up with a more thoughtful response.
Right.
So this shift towards smarter inference, that sounds like it really changed things.
Yeah, it's exciting.
But what about the practical stuff, like energy consumption
Oh, yeah.
or, data scarcity?
Right.
Those are becoming big concerns.
Absolutely. Training these massive models takes a ton of energy,
Yeah.
and it's a big environmental concern. And the thing is, we're getting to a point where finding good training data is becoming a real bottleneck.
So where do we go from here? If we can't just keep scaling up,
Right.
what are the alternatives?
Right. What are researchers doing about this?
Yeah.
Well, one really fascinating example is AlphaGo Zero.
Okay, yeah, I've heard of that.
This AI, it learned to play Go at a superhuman level.
Amazing.
But get this, it didn't learn by being fed millions of human games. It learned by playing against itself.
So it created its own data, basically.
Yeah.
Through self-play. That's amazing. Sounds like science fiction.
It really does. AlphaGo Zero shows us the potential of synthetic data to solve that data scarcity problem.
Right.
We don't always need those massive data sets of real-world information.
Okay.
We can use AI to create its own training data.
Wow.
It opens up a whole new world.
That's incredible. So instead of gathering more and more real-world data, yeah.
Which is expensive and takes forever.
Right.
We can potentially use AI to just generate its own data.
Exactly. That's wild.
It is. And it's not just about solving that scarcity issue either.
Okay.
Synthetic data can help create more balanced and diverse data sets,
Right.
which can actually help reduce bias in AI models.
That's really important.
It's a really powerful tool.
It's almost like,
Yeah.
like we're using AI to create better AI.
Yeah. That's a great way to put it, like a positive feedback loop of innovation.
Exactly.
And this leads us to another area where those traditional scaling laws are being challenged.
Okay.
The whole concept of broken scaling laws.
Broken scaling laws. That sounds interesting. What's that all about?
We've been talking about how those scaling laws usually predict this
Yeah.
smooth, continuous improvement in performance as we scale up the model and the data.
Right.
But researchers are finding these sudden jumps in performance,
Yeah.
like breaks in the curve.
So instead of gradual improvement, there are these sudden leaps forward.
Exactly. And these breaks, they might actually show that entirely new capabilities are emerging.
Oh, wow.
For example, we're seeing these larger models suddenly doing things like in-context learning and chain-of-thought reasoning,
Wow.
things that weren't there in the smaller models, even with more data.
So the model suddenly, like, develops this whole new level of understanding.
Yeah, almost like that.
Reasoning ability.
Yeah,
It makes you wonder what else is hidden in these massive networks.
absolutely. It's one of the most exciting and mysterious
Yeah.
parts of AI research right now.
Right.
These emergent abilities, they're changing our understanding of how intelligence might even work
Right.
and how AI could evolve
Yeah.
in ways we never even thought of.
Yeah, it really feels like we're at this turning point. Like we've been riding this wave of scaling laws.
Right.
And now we're kind of seeing the limits. The question is, what's next?
That's the big question, isn't it?
Yeah.
Researchers are looking at a lot of promising directions. One is trying to develop more efficient training methods,
Okay.
ones that can work with less data and computing power.
That makes sense, especially with all the concerns about the environmental impact.
Exactly. Another thing they're looking at is new architectures,
Right.
ones that are just inherently more efficient and adaptable.
So it's not just about making bigger networks.
Right.
It's about finding completely different ways to approach AI.
Yeah.
That's a big change in how we think about it.
It is. It's a change that's being driven by the limits of scaling,
Yeah.
but also by the incredible potential we're starting to see,
Yeah.
like beyond just making things bigger.
It's really exciting. It feels like we've come so far
Yeah.
thanks to these scaling laws.
Right.
But the biggest discoveries,
Yeah.
they might still be ahead of us.
I think so.
It's amazing.
It is. And for you listening, what's really important to understand is that AI scaling laws,
Yeah.
even with their limitations, they've totally changed AI.
Right.
They're not just some abstract idea.
Yeah.
They're the reason behind so much of the progress we see.
It's like we've been following this map of bigger is better,
Right.
and now we're realizing there's this whole new world out there beyond the edge of the map.
That's a great analogy.
We've gone from just scaling up models
Right.
to focusing on smarter ways to train them,
Yeah.
refining how we use data,
Exactly.
even pushing the boundaries of what AI architectures can even look like.
It's a really exciting time.
That shift is so important.
It is.
It shows that AI research is, like, maturing.
Yeah.
moving beyond brute force
Yeah.
toward really understanding how to unlock intelligence itself.
I agree.
And that brings us to the big question.
Yeah.
What does the future hold?
Right.
As researchers hit these limitations of scale
Yeah.
and start venturing into these uncharted territories,
Right.
what breakthroughs might be just around the corner?
That's the question, isn't it?
Yeah, it's a question that really gets you thinking. Imagine AI that can learn from just a little bit of data,
Right.
adapting to new situations with incredible flexibility.
Yeah.
Or AI that can understand why things happen,
Right.
not just the patterns.
Exactly.
What about AI that can design new technologies, speed up scientific discovery in ways we can't even imagine right now?
It's mind-blowing.
Those possibilities, things that seem like science fiction,
Yeah.
they suddenly feel possible.
They do. And for you listening, the key takeaway is this. Stay curious.
Yeah?
Keep learning about these new trends. The future of AI is being shaped right now.
Right.
And understanding these core ideas will help you understand this amazing journey.
Absolutely. So instead of gathering more and more real-world data, which is expensive and takes forever,
Right.
we can potentially use AI to generate its own training data.
Exactly. And it's not just about, solving that data scarcity issue.
Right.
Synthetic data can be used to create more balanced data sets, more diverse data sets, which can actually help reduce bias in those AI models.
That's important.
Yeah, it's really powerful.
It's almost like we're using AI to create better AI.
It is, yeah. That's a great way to put it. It's like this positive feedback loop of innovation.
Exactly. And this kind of leads us to another area where the traditional scaling laws are being challenged.
Oh, yeah.
This idea of broken scaling laws.
Broken scaling laws. Okay.
What's that all about?
Well, we've been talking about how scaling laws usually predict this smooth, continuous improvement
Yeah.
as we scale up the model and the data.
Right.
But what researchers are finding is that sometimes you get these sudden jumps in performance,
Okay.
like breaks in that curve.
So instead of a gradual improvement, we see these sudden leaps forward.
Exactly. And these breaks might actually be showing that entirely new capabilities are emerging.
Wow. Okay.
Like, for example, we're seeing these larger models suddenly able to do things like in-context learning
Okay.
and chain of thought reasoning, things that weren't there in the smaller models, even when they had more data.
So it's like the model suddenly develops this whole new level of understanding,
Yeah, it's almost like that.
reasoning ability.
Yeah,
It makes you wonder what else is hidden in these massive networks.
absolutely. It's one of the most exciting and kind of mysterious
Yeah.
parts of AI research right now,
Right.
these emergent abilities. I mean, they're changing how we understand how intelligence might even work
Right.
and how AI could evolve in ways we never even thought about.
It feels like we're at this turning point. We've been riding this wave of scaling laws,
Right.
but now we're starting to see the limits.
Yeah,
So the question is, what's next?
that's the big question, isn't it?
It is.
Researchers are exploring all these different promising avenues.
Okay.
One of them is focusing on how to develop more efficient training methods,
Okay.
ones that could work with less data and less computing power.
That makes sense with all the concerns about the the environmental impact. Yeah.
Exactly. Another area they're looking at is new architectures,
Okay.
ones that are just inherently more efficient
Okay.
and adaptable.
So it's not just about making bigger networks.
Yes.
It's about finding fundamentally different ways to even approach AI.
Yeah,
That's a pretty big shift in how we think about this.
it is. It's a shift that's being driven by those limits of scale,
Right.
but also by this incredible potential we're starting to see,
Yeah.
like beyond just making things bigger.
This is really exciting. It feels like we've come so far with these scaling laws,
We have.
but it seems like the most incredible discoveries could still be ahead of us.
I think so too.
And for anyone listening, what's really important to understand is that AI scaling laws, even with their limitations,
Right.
they've totally changed AI.
They have.
They're not just some abstract concept.
No.
They're the driving force behind so much of the progress we're seeing.
Yeah. It's like we've been following this map, this bigger is better map. And now we're realizing that there's this whole new world out there beyond the edge of the map.
We've gone from just scaling up models to focusing on smarter ways to train them.
Exactly.
Refining how we use data.
Right.
And pushing the boundaries of what these architectures can even look like.
It's a really exciting time to be involved in this field.
That shift is so important. It shows that AI research is maturing,
Yeah.
moving beyond brute force
Right.
towards a deeper understanding of how to unlock intelligence itself.
I completely agree.
And that brings us to the big question, right?
Okay.
What does the future hold?
Right.
As researchers grapple with these limitations
Yeah.
and start venturing into these uncharted territories,
Right.
what breakthroughs might be just around the corner?
It's the question everyone's asking.
It is. It really gets you thinking. Imagine AI that can learn from just a tiny bit of data,
Yeah.
adapting to new situations with incredible flexibility.
It'd be amazing.
Or AI that can actually understand why things happen, not just patterns.
Right. The cause and effect.
Exactly. What if AI could design completely new technologies, speed up scientific discovery in ways we can't even fathom right now?
It's mind-blowing to think about.
Those possibilities that used to seem like science fiction,
Yeah.
they suddenly feel within reach.
They do. And for you listening, here's the takeaway. Stay curious.
Right.
Keep learning about these trends. The future of AI is being shaped right now.
It really is.
And your understanding of these core ideas will help you navigate this incredible journey.
Absolutely. It feels like we're really on the edge of something brand new with AI.
Yeah.
Not just about size anymore, but efficiency,
Right.
adaptability, maybe even totally new ways of learning.
And for our listeners, what's important is that even with those limitations we talked about,
Yeah,
scaling laws have totally changed AI research.
it's true.
They're not just some abstract concept.
Right.
They're driving all this progress we see.
It's like we've had this map.
Yeah.
Bigger is better. And now we're finding all these new continents to explore.
That's a great way to put it.
You've gone from scaling up models
Yeah.
to figuring out smarter training,
Right.
being more careful with how we use data,
Exactly.
even changing what AI architectures can look like.
That shift is so important.
It really is.
It shows that AI research is growing up,
Yeah.
moving past just brute force
Right.
to really understanding intelligence itself.
So the big question is, what's next?
Yeah.
Researchers are dealing with these limitations of scale,
Uh-huh.
going into uncharted territory.
Right.
What breakthroughs are coming?
It sparks the imagination, doesn't it?
It really does. Imagine AI that can learn from almost no data,
Yeah.
adapt to anything.
Remarkable.
Or AI that understands why,
Right.
not just patterns.
The cause and effect.
What about AI that can design new technologies?
Oh, wow.
Speed up scientific discovery in ways we can't even think of.
It'd be incredible.
Those possibilities used to be science fiction. Right now they feel possible.
And for you listening, the takeaway is this.
Yeah.
Stay curious. Engage with these new trends. AI is being shaped right now,
It is.
and your understanding will help you navigate this incredible journey.
That's all the time we have for today's deep dive into AI scaling laws.
It's been a fascinating discussion.
Thanks for joining us.
Keep those questions coming.
Until next time, keep exploring.